Hello, welcome to Lead Programmer. Today we are going to look at the question valid parenthesis. So we are given a string which contains just the common type of brackets as shown here, and we have to determine if the input string is valid. And how do we determine if an input string is valid? We have some rules. Open brackets must be closed by the same type of brackets. So it states that we cannot have situation like this. Um, this or this is a completely valid situation. Also, open brackets must be closed in the correct order, right? So the order in which it's closed should be correct. We cannot have some scenario like this, where the order in which the brackets are closed is not correct, right? Because here we have a square bracket and here we have a simple bracket. It should have been first opening square bracket is closed by a closed square bracket, and an opening simple bracket is closed by a closed simple bracket. Also, every closed bracket has a corresponding open bracket of the same type. Okay, so the type of the closing and opening brackets should be the same, and it should be closed in the correct order. Let's look at some examples. So here it's a pretty simple example. We have a pair of simple brackets, so we return true. Here again we have a pair of all three brackets and it meets the criteria, so we have true. This is false because here for an opening simple bracket we have a different type of closing bracket. It should have either been something like this or something like this, or perhaps something like this, because we need all the types of brackets to be present, and the order in which they close should match as we stated earlier. Okay, so there are a couple of ways to solve this. We can essentially use counters to count each type of brackets, see where they occur, and have all sorts of variables to keep track of it. But I'm going to jump to the most efficient solution for this type of question, or perhaps any matching questions that you see. It's worthwhile to consider using a stack to implement such a solution. So, what's a stack? Stack essentially follows the principle of last in, first out, which means the last element to enter would be the first element to leave. Something like a stack of books. So, if you have a stack of books, it's we generally remove the book on the top of the stack, which is the book which has entered the stack at the very end. Now, how do we translate the question to a stack? Let's look at the example over here. So, there's one simple criteria for each opening bracket. We need a corresponding closing bracket. So, which means that, okay, when we encounter an opening bracket, okay, that's good to know. We have to keep track of it somehow. And when we have a closing bracket, we have to ensure that that closing bracket has a corresponding open bracket and it's in the correct order. Now we want to keep track of the order, and to keep track of that, we can potentially consider using a stack, because order matters. And um, whenever we encounter a closing bracket, we know that the most recent opening bracket must be of the same type. Hence, we get an idea of the first out principles of last and first out, which is a stack. Okay, so let's see how it goes. Um, so we start here. We see it's an opening bracket. Okay, if it's an opening bracket, it's good to know. We have to keep track of it. So let's push it on to the stack. Next, we see an opening square bracket. Awesome. Let's push it onto the stack. We see an opening simple bracket. Awesome. Let's push it onto the stack. We see an opening curly bracket. Let's push it onto the stack. Okay. Now we encounter a closed curly bracket. So, uh, in order to preserve the order and check if it's of the same type, we check the top of the stack. Does the encountered bracket correspond to the bracket on the top of the stack? It does. So everything is good. So we continue, and we also pop this from the stack because it's already used. Now we encounter another closing bracket. So the same thing, we check the top of the stack. It's the same, so we are good. We just pop this from the stack and we continue. Now we encounter an opening bracket. Okay, that's good to know. We keep track of it. We push down the stack. Oh, okay, now we encounter a closed bracket. So we see the top of the stack. Awesome. So the top of the stack has the same type of bracket. That's great. We continue. Now we encounter another closing bracket. We check the top of the stack. It matches. Great. We pop it. And the same thing for the last one. We pop and then stack is empty because everything is processed successfully. At any point, if the closing bracket did not match the top of the stack, then we return false. We also have to handle a few edge cases like in this scenario. In this scenario, the stack just looks like this. So to handle this, we have to check whether the stack at the end is empty or not. Same thing goes with this scenario over here. In this scenario, the stack is empty, but there's nothing on the stack. So we have to check the top of the stack. So we have to ensure that if the stack is empty, then it's not possible to check the top of the stack, and hence we return false. Same thing goes with here. Another cute thing to note is the length of the string should always be even, because if the length is not even, it means that there's some there are some pairs of brackets which are not as expected. Again, it's not a foolproof method, but a quick check, because we know that if the string length is not even, then it's definitely false. But if it is even, then it may or may not be false. Awesome. Now let's look at the code quickly. Um, so to begin with, we have a hash map brackets where we have opening brackets. So we have a key value pair. Key corresponds to the closing brackets. Value corresponds to the opening brackets. It's just a cute way to represent brackets. We could just hard code it. That's totally fine. Then we have a quick check. If the length of the string is odd, then we return false, as explained above. We can put this in the solution. It definitely helps make it faster for some scenarios where if the length is false, we just return. But if we don't include it, that's fine too. The time complexity remains the same nonetheless. Then we have a stack called tracker, and we go through each and every character as I had done in the dry run. For each character, if the character is in the value, so if the character corresponds to any opening brackets in the brackets hash map, then we just keep track of it. We just put it in the tracker. We just put it in the stack. If it's not an opening bracket, then it has to be a closing bracket, because according to the given constraints, S contains only these parentheses, right? So if it's not opening brackets, then it has to be closing brackets. And if it is a closing bracket, then here we check the top of the stack. If the top of the stack does not correspond to the same bracket, because brackets at character gives us the corresponding closing bracket, so we are just checking for the equality. So if the brackets are not equal, then we have to return false. Or if the tracker is empty, right, to handle the scenarios mentioned over here, to handle that scenario, we also want to check if the tracker is empty or not. So if it is not, so not tracker checks. So if tracker means that tracker is not empty. If not tracker, it means tracker is empty. So if the tracker is empty or it does not meet the criteria, we just return false. And if everything is good, we can just pop the bracket from the tracker as explained before. At the end, we return true if everything is good, and the tracker should not and the tracker should be empty, right? Not tracker means the stack, the tracker should be empty. Why? To handle the scenarios explained here. Because let's say we have a scenario where everything is good, but we have an opening bracket at the end. In that case, the stack would contain an opening square bracket. So the stack should be empty if everything is good. All right. So yep, that's the solution, and the time complexity of this is the big O of n. That's because we go through the entire string once. Awesome. So I hope you found this helpful. Thank you so much.